Elastic potential energy. Elastic is a word that's used to describe a substance that, when bent, stretched, or compressed, it quickly returns to its original shape. And that's opposed to something that is described as being plastic, which is an object that, when it's bent, stretched, or compressed, it stays in that shape. Elastic potential energy is energy stored when an elastic object is bent, compressed, or stretched. For example, the energy that's used to bend a bow back is then stored as elastic potential energy until the bow is released. And then, when the bow is released, the elastic potential energy of the bow is quickly converted into the kinetic energy of the arrow. Um, it happens very quickly, and you can only really see it in a slow motion video. So this next thing is a slow motion video, and you can see when the string is released on the bow, the arrow flies away really quickly. Now I want you to notice in this video that when the string is released on the bow, that the arrow itself bends and then springs back to its original shape and then flies away kind of wobbling. So even the arrow itself is elastic. When it's bent, it quickly springs back into its original position. Now, the thing about using a bow is that when you use a bow, you lose energy. You put more energy into pulling the bow back than the bow will put into the arrow to make it go flying away. So when you use the bow to fire an arrow, you're actually losing energy. It seems like you'd be better off just throwing the arrow, and then you don't have, there's not as much chance for energy to be lost. When you use the bow, you put more energy into pulling the bow back than the bow will put into the kinetic energy of the arrow. So the question is, well, why use the bow? And the difference is here that the bow is able to do work on the arrow much quicker than you would be able to. So the bow itself has more power than you do. You slowly pull back on the bow, and then the bow very quickly puts that energy into the arrow. And that's how you gain by using the bow. It has more power than you do. There's no way you could throw an arrow as quickly and as far as you could fire an arrow with a bow. The energy still comes from you. The big difference is you put the energy slowly into the bow, and then the bow very quickly puts that energy into the arrow and makes it fly away. Now, there's lots of other things that store elastic potential energy. A mouse trap, when you pull the bar back, it, it bends the spring and then stores energy as elastic potential energy. And when it's tripped, that elastic potential energy is quickly converted into kinetic energy. Another example is prosthetic running feet. They're designed to store elastic potential energy and convert it back into kinetic energy. The kinetic energy of the foot hitting the ground is stored as elastic potential energy, and then that's converted back into kinetic energy to help propel the runner forward. This video just shows a runner with two prosthetic running feet running on a treadmill, and watch the one with the lights on it there. Watch how it bends and then springs back to its original shape. And you can see that also in this video of a runner on a track running with two prosthetic running feet. They are elastic, so they bend and then spring quickly back to their original shape. Now, this idea can also be used for recreation. You can see this guy here has these things on his feet, and those yellow bars in the back are elastic. When bent, they quickly spring back to their original shape. So he can store elastic potential energy in those yellow bars, and then that energy, that stored elastic potential energy, can get converted into the kinetic energy that is able to propel him up and over the bar there. And of course, as you can see, this guy should definitely be wearing a helmet because he could injure himself doing that. Another example is with a tennis ball. The energy used to compress a tennis ball when you hit it with a racket, that energy is stored as elastic potential energy. And then When the tennis ball springs back to its original shape, that elastic potential energy is converted into kinetic energy. If the tennis ball, if you try to hit a ball of clay with a tennis racket, when you hit it, it'll compress, but it won't spring back to its original shape. So you won't get that energy back as kinetic energy. In this video, you're going to see a tennis ball get hit by a tennis racket. It's going to come into the frame in a moment. Watch for the tennis ball to compress and then spring back to its original shape. There we go, and then fly away off the tennis racket. This shows a tennis ball being fired at a racket, and it just shows how much the tennis ball is able to compress and then spring back to its original shape. And when a tennis ball hits the ground, watch it compress, spring back to its original shape, convert that elastic potential energy back into kinetic energy. Now, it's not just tennis balls that do this. Baseball compresses to a surprising degree and then springs back to its original shape. Again, if the baseball was plastic, if it was made out of something like clay, it would compress, but it wouldn't spring back to its original shape, so you wouldn't be able to hit it very far. You would lose that energy that went into compressing the ball would be converted into unusable thermal energy, and you wouldn't get it back as kinetic energy. And this is also true for golf balls. Watch the compression and then watch for it to spring back to its original shape. And the same is true with footballs. When you kick a football, if it's pumped up with air, it will compress but then spring back to its original shape, so you get that kinetic energy back. Now watch this clip right here. Watch for the football to compress and then spring back and then fly away. And watch this again, but this time watch the foot and watch how when the foot kicks the ball, the foot bends and then springs back to its original shape. So the foot itself is also elastic. And here's another example where she's suspended by these two big rubber bands that go up to those posts up there. The energy that's going to be used to stretch those elastic bands there, that energy gets converted into elastic potential energy, and then that elastic potential energy is going to be converted into kinetic energy, as you're going to see. So here it is, storing that energy as elastic potential energy, and then there's the kinetic energy. Now, the thing about this is the energy that you put into something that's elastic, the energy that goes into stretching, bending, or compressing something that's elastic, that energy can be converted into kinetic energy, but the kinetic energy that you get out can never be more than the energy you put in to bend, stretch, or compress the elastic object. So in this video here, watch for the amount of energy they put into these rubber bands in stretching them. Okay, there's their sleeping buddy there, and they're going to pull it back. Not a whole lot of energy goes into stretching those rubber bands, but then when they let go, they seem to get a lot more energy out than the energy that they put in. So you can, of course, tell that this is fake, because you can't get more energy out than the energy that you put in.